DahReply's AI Podcast, your trusted take on the latest AI news. Episode 9, Leju Robotics Iron Womb, the factory that changes everything.
I want you to just imagine something for a second. You are a business leader. Maybe you're running a bustling logistics hub over in Selangor, or, leading operations at a tech firm right in the heart of Kuala Lumpur.
Mm-hmm.
So you walk into your office or your warehouse on a Monday morning to greet your absolute newest hire. But your newest hire isn't sitting at a laptop.
Right.
In fact, your newest hire isn't even human. Your newest hire is the machine itself. And it was fully assembled just 30 minutes ago on a production line in a factory in Guangdong.
It really sounds like a pitch for a science fiction film, right? But it is the exact tangible reality we're stepping into at this very moment.
Yeah.
The sheer velocity at which this physical transition is happening it's staggering. And it's catching a lot of legacy industries completely off guard.
And that is our mission for this deep dive. We are exploring the absolute explosion of what the industry is now calling physical AI. Our primary focus today is on Leju Robotics, specifically their unprecedented, fully automated humanoid factory.
Yeah.
But we're also going to examine the rapidly surging costs of the AI brains required to power these machines.
And how the massive, honestly, somewhat brutal workforce shifts hitting tech giants right now, how that will directly affect businesses in Malaysia and across the globe.
Right. Okay, let's unpack this, starting with the physical hardware. Because for the longest time, a humanoid robot was basically just a really expensive laboratory showpiece.
Yeah, they were YouTube novelties. You know the one?
Oh, yeah, the backflip.
Exactly. You'd see this highly choreographed viral video of a robot doing a backflip or carefully picking up a delicate egg on a soundstage. But a staged, tightly controlled demonstration is a completely different universe from industrial scale manufacturing.
Right. You can't run a warehouse on backflips.
You really can't. So we are finally moving away from the conceptual idea of physical AI and into the gritty mechanical reality of building these machines at a massive industrial scale.
And the absolute epicenter of this shift is a facility in Foshan, Guangdong. It's a joint venture between Leju Robotics and a company called Dongfeng Precision.
Mm-hmm.
And, we aren't talking about a boutique research lab here. This is reportedly China's first automated production line capable of producing 10,000 humanoid units annually.
The output metrics coming from this facility are they're difficult to wrap your head around. They're churning out one fully finished humanoid robot every 30 minutes.
Let's pause on that. 30 minutes. You can barely get a decent lunch delivered to an office in 30 minutes, and they are building a highly complex, autonomous bipedal machine in that same window. How is that even mechanically possible?
Well, it's possible because they've broken down the assembly into 24 distinct automated precision processes.
Wow.
Yeah, and it's constantly monitored by 77 all-dimensional inspection points. They aren't just bolting heavy metal together here. Take their most precise transmission components, for example. The manufacturing error margin is strictly controlled to within 0.02 millimeters.
Okay, so for our listeners who, deal in logistics or software rather than mechanical engineering, why is a 0.02 millimeter tolerance so critical? What happens if it's 0.05 millimeters?
Cascading failure.
Really?
Yeah. When you're building a heavy bipedal robot with multi-degree of freedom joints, any slight microscopic misalignment compounds rapidly. If a knee joint or, say, an ankle actuator is off by just a fraction of a millimeter...
It throws the whole thing off.
Exactly. The robot's internal balance algorithm has to constantly overcompensate just to keep the machine standing upright.
Oh, wow.
And that constant overcompensation drains the internal battery exponentially faster, and it physically burns out the servo motors.
Yeah.
You need that microscopic level of precision if these machines are actually going to survive working a 24/7 shift in a warehouse without, catching fire or breaking down.
That makes total sense.
Yeah.
Let's talk about the actual product rolling off this automated line, though. It's Leju's flagship model, known as Quavo. And the price tag is sitting around $50,000. That feels like a massive threshold crossed. It pulls the humanoid robot out of the realm of multi-million-dollar R&D experiment and drops it firmly into the realm of a standard capital equipment purchase for a medium-sized enterprise.
Yeah, $50,000 is roughly the fully loaded cost of an entry-level logistics employee in many Western markets.
Yeah.
But, this is a capital asset you can actually depreciate.
Right. And looking at the specs, Quavo runs on Kaihong OS, which is an industrial offshoot based on Huawei's Harmony OS. But for a business leader listening to this, why does the operating system on a piece of physical metal even matter?
Because a robot cannot exist in isolation. If you buy 10 of these robots for your warehouse in Selangor, they need to communicate flawlessly with your existing inventory management software.
Like your automated conveyor belts in your local servers.
Exactly. An industrial OS, like Kaihong OS, is designed specifically for the Internet of Things. It ensures the robot natively speaks the same digital language as the rest of your facility's infrastructure.
That integration is huge, and the hardware itself is also wildly impressive. Quavo features joints with 360 newton-meters of torque.
Yeah, that's serious power.
Just to put that physical force into perspective, a high-end industrial power drill maxes out around 60 to 80 newton-meters. So 360 means this machine can catch a falling crate of dense industrial parts without its internal gears stripping or its digital knees buckling.
Exactly.
But I want to pivot to how they are building it, because they're utilizing what's called a Tier 1 contract manufacturing model.
Yes, and this is the structural secret to their speed. Dongfeng Precision, the partner in this venture, is traditionally known for manufacturing massive corrugated packaging equipment.
Okay.
So they are providing the heavy manufacturing muscle, right? And the automated guided vehicles moving around the factory floor. Leju, on the other hand, provides the brain and the overarching design.
Here's where it gets really interesting to me. This is no longer a science fair. It's becoming the Foxconn model for humanoids. They're splitting the labor exactly the way the smartphone industry did over a decade ago. Apple focuses on designing the iPhone. Foxconn focuses on stamping them out by the millions. In this scenario, Leju designs Quavo, and Dongfeng builds it at a relentless scale.
It's the exact same playbook.
But I got to play devil's advocate here for a second. Was browsing the Reddit community r/singularity, and users there were meticulously analyzing the promotional video clips released from this Foshan factory.
Oh, I saw that.
The skepticism was extremely high. People were pointing out that in the final assembly shots, you can clearly see human hands reaching into the frame to adjust cables or secure parts.
Yeah.
So are we really at 100% automation yet, or is this just very clever, highly edited marketing?
What's fascinating here is how perfectly that community reaction captures the current state of the industry. It's this mix of intense hype and rigorous audit. The skeptics are completely correct to point out those human hands.
Right, they aren't faking the screenshots.
No, not at all. Achieving true 100% lights-out automation, where absolutely no human touches the machine, from raw aluminum to the final cardboard shipping box, that is incredibly difficult. Tasks like flexible cable routing, delicate parts supply, and final sensory calibration often still require a human touch. But the optimists in that forum see the real signal hidden beneath the marketing noise.
Okay, broke down that signal for us. What are the skeptics missing?
The signal is the feedback loop. The entire industry is fundamentally shifting its focus from look at our robot walk to look at how we manufacture the robot.
Oh, interesting.
This is the vital first step of robots eventually building other robots. The mere fact that a company is attempting a mixed model flexible assembly line for complex humanoids at a cadence of 1 every 30 minutes means the primary bottleneck has shifted.
Right.
It's no longer a question of can we build one functional robot? The question is now, how fast can we build 10,000?
Okay, so the hardware problem is actively being solved in places like Guangdong. They're stamping out the physical bodies at breakneck speed. But a $50,000 piece of high-torque hardware is just an incredibly heavy, expensive paperweight without the software to actually drive it.
Exactly.
And that brings us to the global brain bottleneck. Hardware is scaling, but software is hitting a wall.
A humanoid robot requires what we call embodied intelligence. It doesn't just need to spit out text. It needs an AI agent capable of deep reasoning, spatial planning, and executing highly complex tasks autonomously in unpredictable, messy environments.
And we are witnessing an absolute explosion in these AI agents right now. Take a tool called OpenClaw as an example.
Yeah, great example.
This isn't just a chatbot sitting in a browser window. It's an autonomous personal AI assistant that lives directly on your computer's operating system. It uses the MCP protocol to connect directly to your WhatsApp, your Telegram, your email, your calendar. It can read a message from a supplier, check your warehouse inventory, and autonomously reply with a shipping date. But stop there for a second. You mentioned the MCP protocol in our notes. If I'm an operations manager, I don't really care about the acronym. I care about what it does. What is the mechanism there?
Think of the MC2 protocol as a universal translator for walled gardens. Historically, your WhatsApp data couldn't talk to your internal supply chain software without a team of human developers building custom, clunky integrations.
Right, a massive headache.
Exactly. MCP creates a standardized bridge. It allows an AI agent to seamlessly reach into different applications, extract the context it needs, and take action across platforms without a human manually copy-pasting data between windows.
It's essentially a tireless digital employee. And as these agents become increasingly autonomous, we're entering an era called the agent economy. If your OpenClaw agent is autonomously negotiating a software subscription or, booking a cargo flight for your logistics business, it eventually needs to pay for those services. But hold on. If my digital assistant is negotiating a contract with a supplier's digital assistant, how is that legally or financially binding? I certainly didn't give an AI my corporate credit card.
And you shouldn't. Traditional financial rails are just too slow and require too much human verification for machine-to-machine commerce. This is why the industry is pivoting toward crypto protocols.
Okay.
There is a protocol called BUY 402 specifically designed for machine-to-machine micropayments, and another called ERC 8004 used for agent identity.
So how does that actually work in practice?
Well, let's say your logistics AI needs to prioritize server space to route a sudden influx of shipping trucks. It can't wait 3 days for your accounts payable department to clear a traditional invoice.
Right, trucks are waiting.
Exactly.
Yeah.
So using ERC 8004, the agent cryptographically proves to the server that it is an authorized representative of your company. Then, using BUY 402, it instantly streams microcents per millisecond from a pre-funded digital wallet to lease that server space autonomously. The agents verify each other, negotiate the price, and settle the transaction instantly, all in the background.
The software capability is genuinely mind-blowing. But here is the massive, unavoidable catch that is terrifying the tech world right now. The compute crunch.
Yeah, it's bad.
Agentic workflows burn through an ungodly amount of computing power. Let's demystify this a bit. We hear the word tokens thrown around constantly in AI pricing. If a business leader is used to paying a flat fee for a software license, what exactly is a token in this context?
Think of a token as a syllable, or a basic unit of thought for an AI model. When you ask a standard AI a question like write an email, it consumes a few hundred tokens to generate the text. But an autonomous agent doesn't just answer a single question. It performs what we call multi-step inference.
Walk us through multi-step inference. What does that look like?
So imagine you tell your agent, audit our quarterly supply chain costs. The agent doesn't just spit out an answer. It writes a draft plan. It opens your internal database. It reads thousands of lines of data. It critiques its own analysis. It realizes it made a math error. It recalculates the numbers, and then it formats a final report.
That's a lot of steps.
Exactly. And every single step in that internal loop, the reading, the critiquing, the recalculating, burns thousands of tokens. An autonomous agent can easily burn through hundreds of thousands of tokens in a matter of minutes to solve one complex problem.
And that massive token burn is currently breaking the business models of the major AI labs. For the last year or so, we've lived in this open bar era of AI.
Yeah, the golden age.
You pay a flat fee, $20 or $30 a month, and your entire enterprise gets unlimited access to world-class models. But the AI companies were heavily subsidizing your business. It was costing them significantly more in raw computing power than they were charging you in subscription fees.
That financial model is mathematically unsustainable when autonomous agents enter the picture. The compute required is just too vast.
And the open bar is officially closing. Anthropic, the company behind the highly popular Claude AI model, is quietly ending their flat-fee subscription tier for large enterprise users. They're transitioning their biggest corporate customers over to usage-based per-token billing to directly offset these astronomical compute costs.
The underlying math is inescapable. Anthropic's revenue recently tripled in a span of just 4 months, rocketing to a $30 billion run rate.
Wow.
That is hypergrowth on a scale we rarely see in enterprise tech. But their physical server infrastructure is buckling under the sheer weight of these new AI agents constantly running those multi-step inference loops. Over a recent 90-day period, Anthropic's API uptime dropped to 98.95%.
Now, to a casual listener, 98.95% sounds like a solid A+ on a university exam. But in the realm of enterprise software, that number is an absolute disaster. That percentage equates to roughly 92 hours of system downtime a year.
Exactly. In the world of enterprise cloud computing, the gold standard is 4 nines, 99.99% uptime. That allows for roughly 53 minutes of total downtime per year. If your logistics company in Kuala Lumpur is relying on an AI agent to run your customer service, route your automated trucks, or operate the Leju robot on your warehouse floor.
You can't have it go dark.
Right. 92 hours of random, unannounced downtime means your entire business effectively grinds to a halt for nearly 4 days.
It's a massive liability. In fact, David Tsai, the founder of the major software platform Retool, publicly stated that he entirely switched his company's infrastructure away from Anthropic and over to OpenAI.
Yeah, I've read that.
He freely admitted that Anthropic's AI model was smarter and better for his needs, but he switched simply because the inferior OpenAI model actually stayed online.
Which is telling.
So I have to ask, if these AI brains are rapidly getting more expensive per token, and they are suffering from major infrastructure outages, is it actually safe to hand over our critical business operations to these agents right now?
That is the multi-million-dollar question keeping CEOs awake at night. You're touching on a concept known in computer science as the coordination paradox.
Right.
AI agents are, by their very design, probabilistic executors. They analyze vast amounts of data to guess the next best action based on historical patterns. But running a business requires deterministic results. You need absolute mathematical certainty that an invoice was paid exactly once, not 0 times, and certainly not twice.
It's like hiring an incredibly creative, visionary artist to do your corporate accounting.
Oh, that's exactly it.
They might guess the most aesthetically pleasing way to balance your ledgers based on industry patterns. But accounting isn't about guessing patterns. It's about exact deterministic math. You want the brilliant intelligence, but you cannot survive the unreliability. The AI is guessing. Your business needs an ironclad guarantee.
That is the perfect analogy. Until the underlying data center infrastructure can guarantee reliable uptime, secure cross-platform permissions, and verifiable deterministic actions, relying entirely on autonomous AI agents represents a major existential corporate risk.
But here is the painful, immediate reality. Companies are absolutely not waiting for the infrastructure to become perfect before they alter their budgets. Which brings us to the human cost of all this.
Yeah, this is the hard part.
If major AI labs are charging exorbitant usage-based fees for API calls, where are the tech giants getting the capital to pay for it? The answer is grim. They are getting the capital by emptying their office buildings. While companies desperately try to figure out hardware scaling in Guangdong and fight software bottlenecks in data centers, they're actively slashing their human workforce to fund it.
The layoffs currently hitting the tech sector are severe. In 2025 alone, over 1.17 million jobs were cut globally across the industry.
1 million.
Over 1 million. That represents the highest level of job displacement since the peak of the pandemic.
Let's look at the specific mechanisms behind these cuts. Oracle recently eliminated 30,000 jobs. Reports indicate this restructuring hit their Indian workforce particularly hard. Why did they do it? So they could shift massive billions of dollars away from human payrolls and directly into building new AI data centers and expanding their cloud infrastructure.
Right.
And it isn't just legacy enterprise behemoths. Snap Inc., the parent company of Snapchat, recently laid off 1,000 workers, representing 16% of their entire full-time staff.
Snap's internal reasoning was explicitly tied to this technological pivot. They were facing immense pressure from activist investors to improve profit margins. In their internal company memo, leadership cited AI optimizations, specifically noting that artificial intelligence is now writing 65% of their software code.
That feels like ripping off a massive, painful Band-Aid. They aren't just firing software engineers because quarterly ad revenues are down. They're actively and intentionally replacing human engineering headcount with machine inference. Are we reaching a point where humans are simply no longer the default workers in the corporate ecosystem?
Well, if we connect this to the bigger picture, it is crucial to recognize that this is not a cyclical economic downturn. During previous recessions, companies trimmed their staff to weather a bad quarter, fully intending to rehire when consumer spending rebounded.
Right, standard layoffs.
This is fundamentally different. This is a structural transformation of the modern corporation. Humans are being permanently displaced to fund the automated future. The capital is migrating permanently from human payrolls to server racks and eventually to fleets of physical robots.
But to justify that kind of massive structural shift, to justify firing tens of thousands of skilled human workers and spending billions on AI compute and automated factories, these new machines have to prove they are infinitely capable. You can't replace a human with a machine that is merely okay. The robot has to be bulletproof.
Which brings us to the extreme physical testing grounds, the arenas where these robots are being pushed to their absolute mechanical limits to prove they can survive the chaos of the real world.
Before we get into the specific stunts, let's look at the macro geopolitical race driving this. It really comes down to the U.S. versus China. Based on the current landscape, the U.S. is successfully cracking the intelligence stack, the complex reasoning, the multi-step inference, the autonomous agentic behavior. Meanwhile, China is mastering the rapid hardware scaling. They're producing robots at that $20,000 to $30,000 price point, with the explicit public goal of driving the unit cost down to just $5,000.
The economic implications there are staggering. If you can combine the profound intelligence of the U.S. software stack with a $5,000 mass-produced Chinese hardware body, you completely rewrite the foundation of the global labor economy. But to convince a logistics company to buy a fleet of $5,000 robots, the hardware cannot be fragile.
Right, and to prove they aren't fragile, these companies are putting their robots through trials that sound genuinely absurd.
Yeah, they do.
For instance, there was a highly publicized half-marathon recently held in Beijing. A humanoid robot named Lightning, developed by the Chinese smartphone manufacturer Honor, didn't just casually run the 21-kilometer race.
Yeah.
It won. It crossed the finish line in 50 minutes and 26 seconds.
To put that achievement in context, that time entirely shattered the human world record for a half marathon, previously set by Jacob Kipling. Even more impressively, nearly half of the competitor robots in that race navigated the winding urban course entirely autonomously. They were sharing parallel tracks with 12,000 human runners and successfully utilizing real-time spatial reasoning to avoid collisions.
Why a marathon, though? As a business leader, I don't need a warehouse worker who can sprint 21 kilometers. I need someone who can carry boxes.
You have to look at the mechanics of the test. A marathon isn't really a test of speed for a machine. It is a grueling, relentless test of thermal endurance and battery optimization.
Oh, because of the heat.
Exactly. A robot's internal motors generate immense heat. If a machine can successfully regulate its thermal output and efficiently manage its power consumption while running at high speeds for 21 kilometers, it can effortlessly operate for a standard 12-hour shift, walking around a massive logistics hub without overheating or requiring a mid-shift recharge.
As if getting outrun by a robot wasn't enough for humanity, we're now seeing these machines step into the fighting ring. A robotics startup called Engine AI is currently prepping a combat-ready robot designated as the T-800.
Yeah, the T-800.
I mean, they are entering this machine into literal combat competitions with names like Robot Boxer and Mecha King.
The terminology is definitely aggressive. And then there's Zhongqing Robotics, a company founded by Zhao Tongyang, the former head of XPeng's robotics division. They recently released a promotional video for their own T-800 robot. And yes, the industry-wide Terminator references are very intentional.
The story behind this video is wild. When the footage initially dropped, people online claimed it was fake. They said the fluid movements had to be CGI. So to prove the physical robot was real, Zhongqing released an unedited behind-the-scenes video where the robot physically kicks its own CEO directly to the concrete ground.
Yeah, I couldn't believe it when I saw it.
The CEO had to wear heavy tactical protective gear. And he still stated on camera that the force of the kick was brutal enough to easily shatter human bones. The company is publicly boasting that this robot possesses an 80% physical performance improvement over a human of the exact same height and weight.
It's wild.
I just have to laugh at the sheer absurdity of a CEO allowing his own robotic creation to violently kick him to the floor just for marketing purposes. Are they trying to build factory workers, or are they literally trying to build Terminators? Why do these machines need to box and fight?
Well, this raises an important question, right? But it's vital to look past the violent spectacle. These aren't just PR stunts aimed at going viral. Think about the mechanical forces at play in a boxing ring. Boxing is the ultimate accelerated test of joint durability and real-time spatial reasoning under duress. Engine AI noted that the internal servos and joints on their newer models can tolerate sudden impacts of up to 100 Gs of vibration.
So when the robot takes a heavy punch or delivers a massive kick to a CEO,
That violent physical shock wave travels through every single titanium servo, every delicate optical sensor, and every line of balance code attempting to keep the machine upright. If the hardware can survive the violent, highly unpredictable, high-impact environment of a combat ring without a catastrophic system failure, it proves a massive point.
the takeaway here isn't that robots are inherently violent. The takeaway is that hardware fragility is no longer the bottleneck. The combat ring is just an accelerated aging test for the warehouse.
Exactly.
If a robot can take a punch in a boxing ring, it can survive a forklift accidentally backing into it on a chaotic factory floor.
Wow.
The physical durability is solved. They're just waiting for the software brains to get cheaper and stop crashing.
Right.
Well, bringing this entire transition back home to you listening to this right now, if you are leading a business in Malaysia, whether that's a manufacturing plant in Penang or a digital agency in Kuala Lumpur, the urgency here is incredibly real. This technological shift is not a speculative roadmap for the next decade. It is happening at this exact present moment. Between Leju's automated facility in Foshan, physically rolling a new humanoid robot off the line every 30 minutes, to autonomous software agents independently writing 65% of the code base at major tech companies, the hybrid human-AI workforce has officially arrived.
The profound capabilities we've unpacked today, from sub-millimeter precision in mass-produced robotic joints to complex autonomous agents dynamically managing corporate workflows, they're fundamentally rewriting the base rules of global economic productivity. The capital is shifting permanently.
Exactly. Which leaves us with one final lingering question to consider as you head into your next leadership meeting. If we have officially entered an era where machines can now rapidly build other machines in automated factories, if AI agents can autonomously write their own software and manage our corporate schedules, and if a heavy bipedal robot can effortlessly outrun us in a half marathon while managing its own thermal output, what is the uniquely human skill you are cultivating in your business today that a machine cannot easily replicate tomorrow? Think deeply about that. We'll catch you next time on The Deep Dive.